Okay, so we'll go ahead and get things started here. So welcome to the Precious Plastic Los Angeles virtual speaker series. And this is our second virtual event, but of the speaker series, we're going to kind of give a longer period of time for each speaker. It is our first one here, and we are so far have three plans. So we're going to also plan one in March and April. So this month we're fortunate to have Cheryl Hartley, who's the founder of Play It Again Plastics, with us, and she did briefly speak in our last meetup and shared some interesting things, and she's continued to do quite a bit of work in figuring out how to 3D print recycled plastic, and so she's identified a very interesting tool to identify what type of plastic it is, and then shreds the plastic, and has tried out a whole bunch of different 3D printers, and has been having some success. She definitely says it's not a production, and there's still improvements need to be made, but she's going to kind of share some of the pros and cons of all the different ones that she's tried out. And just to give you a little introduction to Precious Plastic Los Angeles and what we are. So Precious Plastic Los Angeles, we're the Los Angeles branch of the global Precious Plastic open source recycling project. And so Precious Plastic, if any of you haven't been on preciousplastic.com, you definitely need to go there after this and watch all sorts of their videos and dive into the content. You could probably spend weeks, if not months of your life diving into understanding everything there. But what we're really trying to do, we're kind of one of the first community points is what they've called within the Precious Plastic universe, and that's where we help anybody who's interested in any way to be involved with precious plastic, help connect them in the community, find others that are already have machines or making them. If you want to make something out of recycled plastic, we help try and find organizations. Or if you want to start your own workspace, we kind of help get you kickstarted to finding the resources to do that, or people to partner up with. We do even Precious Plastic Los Angeles. We actually have a shredder and 2 injectors of our own that we loan out to people in the community. So if you're interested, reach out to us about that. Yeah, otherwise I think we'll open it up here. So if anyone wants to, make an announcement to the community, ask a question, share some interesting things you've created. We wanted to just allow kind of a quick 1 minute for everyone who's interested there. And I know looked like Pierre, I think, was one who was interested in that. So let me spotlight Pierre.
I'm here. Can you hear me, guys?
Yeah, there you are.
All right, I turned on my video for the question. I'd like to first start saying that I really admire what this entire precious plastic community is doing. I've been, I think it's been 4 months that I keep browsing preciousplastic.com, and definitely a fan of everything you guys are doing. Hope definitely one day I'll come to LA to see on site what you guys are doing. One of the main question, well, you don't have extrusion or compression sheet, so I'll avoid this type of questions. I'd like to get your opinion on epoxy molding. If you have an 80-20 solution, 80% being shredded plastic and the rest of it being epoxy, one of the Precious Plastic member here in Miami, I forget their name, freeplastic.org, that's what they're doing with tables. And in the middle, they just they pour the shredded plastic and epoxy on top of it. I understand that epoxy is a resin that makes the entire thing non-recyclable at the end. That's kind of the cons of the solution. The pros is that you can dump pretty much any type of plastic because you don't need to melt it down, therefore creating toxic fumes. So if anyone has interest, experience or an opinion on this, I would love to really hear, because I find the molding in silicone very easy to do for pretty much any shape. So I thought this could be another way of using the recycled plastic on top of personally extrusion and compression sheet are the two techniques that I really like. But I do not have anything set up yet, no machines, no nothing. Have experience in the plastic industry from before, injection molding, but really interested to become a member within 1 to 2 years, I would say.
And where are you based?
I'm based in Miami, Florida.
Oh, okay. Great.
It sounds like this would be beautiful, you know, with the plastic kind of floating in the epoxy.
If you can find the Miami partner in, I could even share my screen if you want, but otherwise they're the only one in Miami transforming the plastic. There's another partner building machine. None of them are responsive, and I'm so glad to be watching this WebEx because besides a partner in Idaho that makes machines, I've been struggling to connect with precious plastic community. The partner in Idaho explained me that because of the COVID madness, everybody's in survival mode and they're kind of running out of time to dedicate, you know, educating and so on to whoever wants to join. So that's why I'm really thrilled to be here.
Yeah, one of our founders is now out in Florida running what he calls Precious Plastic Florida, Garrett Cadu. It doesn't look like he's joined here today.
In Tampa?
But he's been working on stuff. I'm not sure exactly where he is. Do you know where he is, Richard? We can connect you afterwards. But just to give a quick response to your question about the resin, you know, I would say it's definitely something interesting. It does make it non-recyclable thereafter, but you know, in general, our vision is whatever you can do to kind of take the plastic out of circulation, where you're not designing it into things that it would ever change, that you would need to recycle it again, is kind of the best, because plastic, that's kind of the problem, is that the recycling ecosystem is kind of broken. So, you know, if you were making it into something that may only get used for, you know, weeks, months, years, then maybe you wouldn't want to do it. But if you're making something that's like a permanent, you know, a table or something that is a beautiful art piece that you would never envision, you know, needing to recycle, then that could be a great solution, and it certainly makes it easier to not have to worry about the melting and such.
Yeah, the pro of the resin.
But we can talk more on that afterwards. If
the pro of the epoxy resin is that it's extremely durable. So even if you were to do just a brick, just for gardening, for example, that brick get used and scratched, you just put another layer of epoxy on top of it, and there you go, you have it repaired. And instead of having a full 100% epoxy base, you can really reduce your cost on building those products because you have an 80-20. I have a little setup here. Honestly, it's not ready to present. I've been playing with it, but it's definitely not ready to present. I'd be happy to share my results whenever I have some conclusions on this. But yeah, no, so far I need to play with the different molds. I'm testing with a clay saucer for plants. I'm testing with a plastic saucer, an aluminum tray, put in different type of grease, WD-40, lithium grease, to see how the releasing is happening or if it's really sticking to those materials. So because I didn't want to invest right away in all the shredder, extrusion machine and so on, that's why I wanted to play with this, which is extremely minimal investment. I think I spent less than $50 so far. And I have a paper shredder just to shred any sleeve of plastic.
All right, yeah, let's chat more, Pierre, after this. At
Thank
the
you.
end, we can hop in a breakout room, or we can even schedule another time, and happy
Sorry,
to
I took way more
talk
than a
as-
minute.
I want to jump in really quickly. Pierre, in the chat, I cut and paste a Megatech Center, a guy named L.
They're not answering.
You've been trying to reach out to them?
I left like 5 voicemail, 5 emails. Nobody answered.
Okay, yeah, 'cause I actually got a compression screw from them, and my original shredder box came from them, but maybe, and that's been a couple years, so maybe it's moved on, or
Maybe because of COVID as well.
yeah.
But if you guys are able to connect me to them or saying that I have an interest, yeah, we can take this offline. Sorry, I'm way over a minute.
Oh, no problem. Thank you for
Thank
your additions and questions. Anybody else? So far, it hasn't looked like anyone else was interested to have specific announcements. And if not, then we can dive straight into Cheryl's presentation. All right, well, we'll let Cheryl take it away. I think you're muted.
There we go. Yeah, that's going to go a lot better. All right, so in just a moment here, you should be able to see my screen. There's not a whole lot on it just yet. You guys see the screen with 3D printing with plastic waste across the front?
Yeah.
Yes.
Yeah.
Okay, awesome, great. So yeah, I'm Cheryl Hartley, and I started plating in plastic last year, like early last year, with no experience with the plastic industry, no experience with being a maker or anything like that, and with the goal of recycling plastic that our local municipal waste companies don't accept, like don't recycle. So I'm trying to divert stuff that's not ever going to get recycled. Toys, plastic toys is like the big thing. I'm also partnering with a lab in Irvine that I just kind of randomly got hooked up with, and they have a ton of polypropylene, which is one of the most commonly used plastics. Like households and stuff use it a heck of a lot. So I'm getting lots of plastic, and that's awesome. So anyway, my business objective is to recycle that kind of plastic that doesn't get recycled by our municipal companies, and 3D print it into household goods. So I'm not doing that yet. I've been working on it for about 14 months, and I've been doing all the other things like the business paperwork and all that junk in the meantime. So it hasn't been a full 14 months that I've been dedicating, time to figuring this out. But it's been a lot of time. It's a hard problem. And this is why you can't just go and buy a pellet eating 3D printer. These things are out there. The pellet extruders that 3D print are out there. However, they're industrial. They're not for maker level folks. They're not for, just regular consumers yet, but they're getting there. Very much an emerging technology. So anyway, today I'm going to talk about what I've learned. I'll look at with you some of the extruders that are out there. I'll look at the one with you that I have, and have some recommendations for you, things to look for. If you want to try, starting this, things to look for in an extruder and in a 3D printer, and how to move forward. So, how do I move the next slide? There we go. All right. So, actually, before we talk about 3D printing basics, I want to take a poll and just ask everybody who has a 3D printer at home, or who has used a 3D printer. So there should be a way to raise your hand in the reactions area. And then Natalia, is that who's going to? I apologize, is going to take a look and let me know because I can't manage all that stuff. Oh, ooh, it tells me right on the screen, 7 people. Anybody else? All right, so a little less than half of us have some experience with 3D printers. So I am going to go ahead and talk just real briefly about just the basics of 3D printing, and it'll just take a couple of minutes. So first thing is a 3D printer is something that does additive manufacturing. It prints in layers, and it has a little print head that melts plastic and extrudes it in layers on a print bed. And 3D printers have 3 axes. They've got the X-axis, which moves the print head left and right. The Y-axis, which moves and then the Z-axis, which moves the print head up and down. And that's the one that creates each of these layers. Can everybody still, actually, yeah, can everybody still hear me?
Yeah,
One of my ear things
Yes,
fell out.
yeah,
Okay, thank you.
We can hear you well.
Well, it just fell out of my ear. Great. So to print something, I'm actually putting this here because when I first started, I really didn't know how to get started, except for the little files that came with the printer that I started with. So if you want to print something, you can either draw it in a AutoCAD type program, or you can download the file. There's so many files out there, so many drawings that people have developed of, you know, Baby Yoda and just everything out there, lamps, all kinds of toys, useful things, you know, household useful things. So you need to get the file, which is generally in a .pst format. And by the way, I have a bunch of notes. I have more content than we really have time for. So I have a ton of notes that I'm actually going to post with this recording when you guys are able to post them wherever I would think the Facebook page. And I'll somehow get a link in there to this presentation because there's a bunch more information and there's going to be links. So anyway, all that to say, there's also lists of the different kind of products that you can use for drawing and the different places you can go to download stuff. So once you have your file, then you use a slicer program. So this is a different piece of software. Most of the time, your 3D printer is going to come with it. Not always, though. It just depends on the printer. And what it does is it interprets that PST file into code that your printer can understand. Generally, it's G-code, .G-code. So it changes all those lines and layers and thicknesses and everything into that code. And then you either send it to your printer on over a USB cable connection from your computer, or you stick it on an SD card, stick it in the printer, use the little screen and print. So it's to me, it was just kind of strange, like, well, what's the difference between this STL, this G code, and all that stuff? So those are the basics of 3D printing. So the way I started, I didn't know that there was such a thing as a pellet extruder that you could stick on your 3D printer because it's not mainstream, you know, because it's such an emerging technology. So I thought I needed to, So I thought I needed to create filament. So that's what I started to try and do. I bought a kit for a Extruder, which is the picture that you see in the center, and for a fill winder, which binds the filament onto your print spool for your spool. And it cost about $500 for the 2 of these things. They were kits. They were actually pretty fun to build. I haven't built anything like that before where I had to solder things and stuff. But I wasn't able to get reliable results. So 3D printers use filament, and that filament, it has really, really tight tolerances. So it has to be perfectly round. It has to be, the exact diameter, and it also has to have the same viscosity. So you can't have like a little more material and the combination of materials in the plastic. So they are not forgiving of changes in the filament, especially width. And I just could not get it to be consistent. Not alone. I did a bunch of research at that time, and if I wanted to go that route, what I would need to do is invest in a prosumer type of system. The one that I found, and I kind of stopped after I found it and changed directions, was about $10,000, which is awesome. And if I wanted to sell filament, that might be something to do, and there's not a lot of recycled filament out there. So it's an idea. But I just wanted something that would work. I didn't want to mess with machines. I just want to be able to do my goal, which is design products, print them, sell them. So I went back to research, and I found that there was one pellet extruder you can attach to your 3D printer that wasn't thousands of dollars. And that was the Mahor V4 Universal Pellet Extruder for $600. I'm not a shill, I swear. I'm going to show you a whole bunch of other ones. And I actually don't recommend it. So, but I have learned a ton, and that's what I'm going to share with you guys. So before we look at the different extruders that I researched, I wanted to go over what a pellet extruder is made up of. And for the most part, they all have these particular components that I have listed here in common. So they start with a geared stepper motor. So let's look at that. So I've got the same extruder here shown all nice and clean and pretty, and then kind of an inside view. And the geared stepper motor is right here. So your 3D printers have stepper motors. Generally, they're not geared. This gearing add right here actually creates more torque. So yeah, I'm not going to go into detail because I'm going to get it wrong. So anyway, it needs to be geared so that you have more torque. And then you have an auger or a screw. So can you guys see my mouse moving around the screen?
Yeah, we can see it.
Okay, cool. Thank you. I wasn't sure if I needed to use the annotate thing. So this stepper motor is attached to this auger or screw, and that is what pulls the pellets down into the heat zone down here. So, but before I get to the heat zone, that auger is inside of a barrel or a heat break tube. Lots of different terms for it. And that's what we're seeing in gray on either side of this screw. This is known as the cold end. And so this little fan, which you see on the left and then right there, kind of light, is trying to keep this as cool as possible so that these pellets don't melt prematurely. And they tend to melt prematurely because you've got this hot end, and it is attached to this heat break tube / barrel. And of course, the heat is going to creep along that metal and then melt the pellets before you want them to melt, and then jam up the works, and it doesn't work right. So that's why you have the fan and other things, which we'll get into. And then you have the hopper. So this is where your either pellets or shredded plastic go in. And I mentioned the heater block down here. The heater block also has a heater in it. So it's just a block of metal, and then the heater is inserted into it. There's a thermistor to check the temperature and ensure that it's maintaining the right temperature, and then the nozzle down here on the bottom. And then this one, it's not real clear in this drawing, but there should also be another fan at the bottom, and it's probably just on the other side of this extruder. And that fan is directed at the print to cool each layer to solidify the plastic. So this is just a generic basic pellet extruder. Let's look at the one that I have. So it came really pretty and shiny and new like this. It doesn't look like that anymore. Being a novice, not knowing what was, going on in there when it would stop extruding or, various things happened. Of course, I took it apart many times. And so it looks like this, except this has opened up so we can see inside. So now we got a real example. So the geared stepper motor is this guy. This is the motor. This is the gearing area. Here's the auger or the screw right there, and it goes inside of this heat break tube. And then here's the heat block. What a mess. It's working fine. And then the heater is probably coming from this cable right here, and then it goes right into the block. And then the thermistor is this one that goes right into the block. And then the nozzle, you can't see it too well. So there's all the components that you pretty much see across the board as based on the experience that I have. And again, I have 14 months of experience. I didn't come from 3D printing. I didn't come from plastic. So I'm still learning. There's so much to learn. So all the things that I share with you today are based on information that I've found or conclusions that I've drawn when things go wrong, and your mileage may vary. All right, that is not. Oh, there we go. So I've got a little close up in here, and what I want to point out is a couple of things. So notice this auger. It is shaped just like a regular, similar to a regular drill bit. It sweeps to the right, clockwise. This area, so this copper or whatever the metal is that this is made of, something nice and conductive, has grooves that are going the opposite way. And so when this screw turns, and it turns to the left, so it'll push rather than pulling, it's actually going against these grooves, and that really draws those pellets down, or the shredded plastic, whatever you have. So that's something that isn't seen in all the extruders. And so that's one of the things that I wanted to point out. Oh, I also wanted to point out all these holes. It did not come that way. It came with these slots, and that's for air to get in here to make this stay a cold zone, and or the cold zone, excuse me, and not have heat creep up and create blockages. But it just wasn't sufficient. And so I put in all of these holes, and then over here you can say I put in a screen because the holes are there, and then the plastic comes shooting out. So I put in a screen, and I installed a fan, a pretty powerful one. And for the most part, it's working to keep this cold enough. It's definitely real hot. So now how to melt the pellets prematurely and then clog up the works. All right, let's look here. Oh yes, so I mentioned that the auger is like a drill bit, but you can see there's a big difference here. It's graduated. So this is the top part, like this is where it would be connected to the motor. This is where it's right before the nozzle. And so what it's doing is it's pulling in plastic here, and you can see it's got lots of room. And then there's less and less room as it's getting down to that heat block and melting. And so that less and less room is going to create pressure so that you've got and it also squeeze out basically the air, because you're going to have, of course, air between all of these little pieces of plastic. So the air goes up, plastic goes down, flows nice, you've got pressure, and then comes out of the nozzle that would be down here. One of the things that I wanted to go over are the kind of features that you want to look for in a pellet extruder. And saying pellet as a shortcut, pellet and shredded plastic extruder that goes on a 3D printer. So the first thing is an effective heat break. I've already kind of gone over what can happen when you get heat creep. And a heat break is the thing that is supposed to stop that heat from going up into the pellets that are getting fed in. That can take a lot of different forms. It doesn't have to just be a fan. There's, let's see here. Oh, so some pellet extruders actually have several heat zones. So on the example we looked at a moment ago, we just had one heat block down at the bottom. But some of the more advanced pellet extruders actually have these heat, I don't remember the term, but they wrap around, and they use several different ones. So you put the hottest one down here, and then the next hottest here, and then this one is cooler, and the screw is way, way longer. So that's one way to deal with heat creep. Another is by using two different kinds of metal, which I think is such a cool idea. So this would be the metal that's, conducted to heat, and this would be kind that stays really cool. They also, some of them are water cooled, and some, like mine, is just with a fan. So another thing you want to look for is that it takes the kind of plastic that you want to use. So I really want to use shredded plastic. Other people might want to buy recycled pelletized plastic from a recycler. And the pellet extruders that I looked at, probably a quarter of them take shredded plastic. So it's something to look for. You want to make sure that it's compatible with your target printer, meaning it's not too big. So if you have a tiny printer, you don't want to put an 11-pound pellet extruder on it. You want to make sure you have the right power. Most of the extruders are either 12 volt or 24 volt. 24 is going to be better. Some of them are 110, but those are more the industrial ones. And you want to make sure that you have all the right connections. So I mentioned a minute ago, some of them have multiple heat zones. I doubt that my printer has 4 thermistors to check to make sure that each heat zone is at the right level. So you need to make sure that you have all the right connections available in your printer.
Cheryl, I have a quick question, if you don't mind.
Yeah, please. Not at all.
Yeah, we're looking at this this lead screw here, and I'm wondering if the plastic is molten near the end of it, near the heat block, or you're trying to keep it solid throughout its motion when you're providing pressure.
No, it should be molten at this point.
Okay.
Yeah, and I mean, I said a minute ago, I'm not the expert, and I only have a little bit of experience, so I don't know at which point it really should become molten, but it's certainly before the nozzle and around the heat block.
But solid near the feedstock. Yeah, so some sort of gradient within there. Yeah, that clears things up. Thank you.
Cool. And just to kind of share with you, so I'm going to back up one. I'm still kind of confused as to why when some of those pellets melt prematurely, they clog it. I don't know why it doesn't just get pulled in. Maybe it's too close to the pellets that aren't melted. So I'm not quite sure why this causes clogging, but trust me, it causes clogging. I've got some samples right here. So Yeah. All right. Let's see here. Oh, we already talked about the graduated auger. Like, go ahead. Did you have another?
Yeah,
question?
sure. One thing that occurs to me when you're talking about why do those pellets get clogged at that position, one of the reasons is because it's not actually being drawn down by the auger at that point. So it doesn't actually have a direction to go, and it ends up clumping together with pellets that are not melted enough, and that just becomes a sticky mess up there. So you really want to have
That
everything
makes sense.
entering in and having that downward pressure to begin with. And once you're in there and you've got all the added friction from the movement, that's when you start to get increasingly molten.
That makes tons of sense. That makes tons of sense. Okay, thank you. All I knew is by the time I got it open so I could see it, it was hard as a rock, so because it cooled off so quickly. Okay, so the heat break tube I mentioned before, I was showing you the grooves in it. That's something that I think is a great feature, and like I mentioned, it's not seen in every single extruder. The stepper motor should be at least a NEMA 17. One of the extruders that I researched actually has a NEMA 24, which is just what NEMA means. It's a bigger motor. Definitely a gearbox. You have to have a gearbox to increase the torque because you're going to have. It's just way harder for these motors to push plastic pellets and shredded plastic through than just moving filament that has like almost no resistance, well, less resistance. Okay, this is a strange one. Retraction substitute. As far as I can tell, based on my research, these pellet extruders do not have retraction. It's just not a thing. And but they need to be able to, well, you would like them to be able to handle retraction in a different way. One of the extruders that I encountered said that they handled it by an anti-ooze mechanism. If you don't have retraction, then you risk stringing, and just depending on the kind of thing that you're printing, that may or may not be a problem. So it's something to consider, something to keep in mind. And then the longer you're, go ahead. Yeah.
But retraction, can you define that for us? Is that the ability for the motor to turn backwards, or?
Yeah, it's not just back, because definitely the motor on these can turn backwards. It's the ability for it to basically kind of suck in a little bit of the plastic on the nozzle, from the nozzle. So when your printer is doing moves and it finishes this layer, and then it's like, okay, I'm going to go over here. You don't want it to dribble on the way, ooze. And so before you move from here to there, the best thing to do is to kind of suck up that plastic a little bit so you can make your move. You don't leave a little string or trail or whatever in between. I'm not sure, I don't totally understand the physics. It kind of makes sense to me, but I can't explain it. But when you turn this clockwise, which is the opposite direction that it's normally headed, it does not suck that plastic back up into the nozzle. And so it is not able to retract. So something to consider. And I don't know how that one particular extruder managed to overcome this with just some sort of an anti-ooze mechanism. But it's just something to consider when you're deciding what you want to print and if a extruder is right for you. The last thing that I could think of for what you want to look for in an extruder is the longest melt zone that your printer can handle. And what that enables is, this is kind of a short screw, and the longer the screw is, the more time that plastic has to melt and stabilize. And so if you're, and actually the faster you can print. If you're trying to print real fast, you're pushing those pellets through, they don't have as much time to melt. So a long melt zone is a good thing. So what, oh, I feel like I guess I did not miss anything. So what extruder is best? It really depends. I didn't find any one size fits all extruder. It depends on what you want to prep. It depends on what kind of feedstock you're using. For example, the cheapest option that I ran across has really low resolution, meaning the bead of plastic that it puts out of the nozzle is pretty large. It can only handle, I can't remember the exact number, but it's probably something like maybe a 1 millimeter, but probably a 2 millimeter opening in the nozzle, which means you're going to get low resolution prints. You can see the lines super clearly. In fact, here's an example. Oh, shoot, I can't tell if it's going to show nicely or not. But you can see actually from this end too, you can see how big those lines are, those extrusions. And so this is super duper low resolution. I have this whole box of tail prints, but every single one of them was a learning experience. So anyway,
Cheryl, then
yeah.
can you make thicker layers too? If it's putting out a much larger bead, then you can make something quicker too, right? So if you're not looking for as
Absolutely.
high a resolution, if you want to make a big object, you can do that, right?
Yeah, absolutely. I was thinking that, you know, it depends on what your objective is. So that cheapest option, which is the trash pan printer, it definitely has its place. Just because it's not going to serve, you know, the kind of thing that I want to print, doesn't mean that it's not going to print other things beautifully. Like I was thinking a floor lamp. For whatever reason, I was thinking like a square floor lamp that's super tall. And if you have a few little holes even and imperfections, I think that it would actually enhance the look of it. And nice thick blinds are going to enhance the look of it. So it just depends on what you're after. So I researched, oh, I'm sorry, I wanted to mention one other thing. The higher the resolution on these pellet extruders, the less likely they're able to take inconsistent feedstock, meaning shredded plastic is not going to work when you're trying to use a 0.4 nozzle. And I'll talk about that a little bit more when we're looking at a couple of these examples. So I researched 12 extruders. We don't have an hour just to look at every single extruder. So I'm going to show you 5, but the rest of them are in slides later on in here that you can take a look at if you want to when it's posted. What else?
Cheryl, you did have there was a couple of questions in the chat just about
how. Oh, I'm sorry.
Oh, it's no problem. I can just read them off. How do you collect plastic?
Please.
And have you experienced issues using recycled plastic that's not 100% clean?
That's a really good question. So how do you collect plastic? I actually have some notes on this. Let me find them. So I reached out. Okay, I guess I got rid of them. It's fine. I reached out to my local community in lots of different ways. So I dropped in on Montessori schools, and some of which were like, get out, and some were super nice. And yeah, sure, you know, we'll let you know when we don't need that, you know, that outside big monster plastic toy, whatever it is. I reached out to people on my vine upping group on Facebook. That's actually why I joined it. And there's lots of other groups that are just like that. Of course, I can't think of them right now, but anyway, there's tons of places where you can get free stuff, and you can actually post in search of ISO posts, and I got a ton of responses that way. That's actually how I hooked up with UCI. One of their labs, they've got like 5 labs. One person at one of their labs saves all the plastic, and you wouldn't think, well, I wouldn't have thought that they would have that much waste plastic. But so they have those little pipettes, you know, and they're doing all those experiments, and then they have a little container that holds, it's got tons of holes that holds those pipettes, and then that sits in a box. It's all plastic, it's all polypropylene. It's perfectly clean, it's beautiful colors, and they used to be able to send it back to the manufacturer, who would either sanitize it or recycle it. They don't take it anymore, probably because it's more expensive to reuse it, unfortunately. So I get it. So there's tons of ways to get plastic for free. Of course, you can partner with your local precious plastic recycler. Like we have, you know, different types of locations, and if you can find one, we're still growing. You can do that. Lots of options. And then the other question. What was the other question? I'm sorry, it was a good one.
Oh, yeah, the other question was, have you experienced issues using recycled plastic that's not 100% clean?
Okay, no, I haven't. However, so the bigger your nozzle is, the more likely you're going to be able to print things when your plastic isn't perfect, you know, when you have some contaminants. I save all of the polypropylene that comes out of our kitchen, which man, it's a lot, it's terrible. You know, take out things, especially now, and so on. And I spend a lot of time cleaning it with goof off, letting it soak. Sometimes the label, you know, it comes off and half the label is still there, and you can actually cut that section out. So no, I don't have a lot of experience with using plastic that's got stuff in it. Your best bet, of course, is to try and get it clean before you shred it. And I would actually, if I needed to figure that out personally, I would probably go to a recycler and ask them how they handle that. Not a recycler that takes in, but a recycler that actually processes and shreds and puts out pellets. And they're pretty. I went to a couple actually in Fontana not for that question, and they can probably share with you how they get through that. So there you go. Big nozzle. Let's look. Where are my notes? Oh, one moment here. Okay, so we did already look at. Oh, were there any other questions?
There were, but maybe
said-
we'll let you continue, and we can answer them at the end, because they're kind of a little more generic than related to the 3D printing. So.
Okay. So we did already look at this extruder, and I just wanted to share a little bit more information. So this was $600, and it came pre-assembled. It is 11 centimeters long from top to bottom. That's the smallest one, actually, that I ran across in my research. It does take shredded plastic up to 4 millimeters on any side. It says that it's open source and you can get almost all of the files. What you cannot get, well, what I've been unable to find, and I do have a question submitted to the company, what I can't find is the design files for the auger and the design files for the barrel. They're really specialized. You know, I would have to take them and have somebody manufacture, and I have no idea how that happens. So maybe that's why. But I think that we'll see. We'll see what they say. So it's sort of open source. What else? And I can't quite recommend it because of the issue with the pellet clogging. But we'll see. You know, I have another one on order from a different company, a totally different extruder, which we'll look at in a minute. And they say they've figured out that issue. But, you know, until you try it, you don't know. There's videos, so that's good. But anyway, all right, let's look at the next extruder. So this is from a company in Australia, and it just barely became available like in the last month or so. This is, here we go. It's from Polylab, and it's called the Bravo. It's $950. It also comes pre-assembled. They require a few weeks of lead time. I don't know how heavy it is. There's not a whole lot of, there's not like a data sheet that I could find. But I do think it looks promising. They said that they have figured out, well, they've improved actually the heat break design. So they went through, created their prototype, played with that, did beta testing, got lots of feedback, applied that feedback to make improvements. One of them was to enhance that coolant. And so they said that they've improved that. And what else? Oh, and they said that actually it can print up to 300 Celsius with, 300 Celsius, which is pretty high, which is really cool, really nice. Yeah, so it looks promising. This is not the one that I ordered though, because this was not available when I was ready to go ahead and throw some more money at this. This is the one that I ordered, and it was a pre-order. Sorry, I keep looking at because I'm looking at my notes. My apologies. Okay, here we go. I found it. So you can buy it in a kit for I want to say $600 or $700. It's $1,000 pre-built, just like this. And they also have a dispenser, which is pretty cool. That it's a little dispenser. It's got a little fan, and then it's got a hose that goes to the top of this, and a sensor that tells the dispenser when it's running out of pellets, and then it'll shoot a few over. So this one looks really promising to me. However, I ordered it in October, and it was a pre-order. I knew I wasn't going to get it right away, but it was for a December 1st ship date, and it's been a long time since December 1st. However, they're working on it. You know, they've been in contact, and COVID really got in their way, and so I'm hoping that I get it pretty soon and I can test it out. I do plan on, well, with my Facebook page, my Play It Again Plastic Facebook page, I'm constantly putting updates, and I'm going to be updating, putting an update on this when I finally get it, and I will cross post so you guys can see it with this recording.
And Cheryl, question: Are these
Sure.
ones you're showing? They're just the 3D printer head, so you need your own XYZ gantry or 3D printer.
You got it.
Okay. So
Yes. Yeah. So this one is much bigger than the others that I've talked about. The reason that I wanted to bring this one up is because it's open source. And it is from a company called Re3D. They have a printer called the Gigabyte X that takes shredded plastic. They've been working on it. I've been watching them and lurking on their website for quite a while. They actually won like $250,000 or something like that to continue to further development, maybe 10 months ago. And they're doing a lot of good, so that's really cool. However, just because it's open source doesn't mean that it's inexpensive. One of my friends spoke with that company and was asking, some questions about how this operates and how to get the files, the open source files. And she explained that, yeah, it's open source, but these components are so specialized that when you go to buy, one here, this component from this company, that component from that company, and so on, you're actually going to exceed the purchase price. They have, in my opinion, they've underpriced their recycle, the Gigabyte X, which is their printer that uses recycled plastic. And I think that it's on purpose. I think that it's so that it'll get sold more. So anyway, this is $2,700 pre-built. That's a lot of money, but it's actually a good deal looking at all the other options that are out there that are industrial size. So it's 11 pounds. It's huge. I don't know how long it is. I wasn't able to find that, like the dimensions. I wasn't able to find that. Let's see. It does take shredded flakes or shredded plastic, excuse me. And what else? Yeah, so 11 pounds is huge. But you don't have to have an industrial printer. You can use a desktop. Like for instance, I have a Anycubic Curon, and it's huge. I would probably have to beef up the y-axis and do a couple other things if I even have all the connections. The thing that you want to consider when you're looking at the extruder is if it's real heavy and you're putting it on a not real sturdy printer, as it's moving around, sure, it's not going to fall off or anything as the gantry, but as it's moving, it's moving kind of jerky, and so when it goes to the side, your printer might move, and then it messes up the print. So there's lots of stuff to consider. So anyway, let's look at the next one. This is the Untitled. What a funny name. It's actually not available yet, but I included it because I am just super excited about this one. It's got a lot of promise. This looks like, so it's got these multiple heat zones. These are the heater bands that I was talking about. And this is one of the things you see in more high-end extruders. But on their website, they're saying that they will have a Kickstarter this month, which is not there, and this is the end of the month, so they're running behind, for $590. And so you give them your $590, and then when they have this available, which will probably take another year, I'm guessing, what a great deal. And my little bit of experience with Kickstarters is, they're giving you this product for way less than they're going to charge. I can't imagine that they're going to charge more than twice the Kickstarter amount. So if that's true, I'm completely speculating, that means this would be like $1,200, and that's a great deal for such a well-developed extruder. So even though it's not available, I did want to bring it up and show you guys this possibility. Oh, and let me see if there's anything else I can share about this. It's 19 centimeters, so it's bigger than the one that I have, the Mahor, but not that much. The Mahor is 11 centimeters, and so this is 19. So it'll need a slightly larger printer but not a big monster printer at all. Another reason why I'm excited about this is it takes shredded plastic, and each piece needs to be 5 millimeters on any given side or less. That's kind of a big size for these pellet extruders. And that's all about that one. So these are the 12. The ones that I spoke about are the orange ones. There's a slide for every single one of these, so we're not going to go over this, but I just want to let you know we've got a bunch of others for you to look at when you have time. Okay, so I'm going to talk about 3D printer considerations. Does anybody have any questions on the stuff we've covered so far before I kind of move on? Linus.
Hey, thank you so much for this, Cheryl. This is fantastic. I was curious about materials. You're talking about how you're mostly working with polypropylene. Do you have much experience working with other types of plastic and putting those shreds into any of these extruders?
I don't. So polypropylene, unfortunately, is kind of a bear to work with. If you were to look at a timeline of all the different filaments as they became available, PLA would probably be first, I would assume, for consumers, and then maybe ABS, and so on and so on and so on. Polypropylene is like way down on the list because it is a pain. I don't know the chemical terms, the chemistry terms, but it warps like mad. And so when you're printing, here's a good example. That is really warped. When you're printing it, it doesn't want to stay on the bed. It also won't stick to anything except for itself. It doesn't want to stick to anything except for itself. So when you put it down on the bed, when the printer puts it down on the bed, it cools a little bit and it pulls up, or it just doesn't behave. And when it pulls up, then the print head hits it, and it's just a mess. So I kind of think that it's the hardest plastic to print with. But yeah, I haven't printed with like PET. I would think would be a real common one to use. I did actually use HDPE a little bit, but that was when I was trying to make filament. It wasn't too terrible, but I really want to be able to print with polypropylene. When I look at what plastic toys are made out of, it's polypropylene and HDPE, and so that's kind of where I stuck my all my time. So hopefully that answers the question. Any other questions before I move on?
Sure, it looked like there was one more
yes.
in the chat from Megan. Have you tried a glue stick trick on the bed to prevent the warping?
Yes, thank you. So some of the things that I've tried are a glue stick, and they actually make, whatever I say that, they make a special kind of glue that's from Maggie Goo. I don't know, Magic Goo. They have lots of different kinds, and this one is specific for polypropylene. I have also mechanically fastened the plastic down. So if we look at this example, I have all this plastic around here, and then this is my actual print that I want. And so this is a brim that you, when you're using your slicer, you can tell it to print one or not. And it worked so badly, and I'm not quite sure why it didn't behave nicely, because I actually fastened it down to the print bed, which is metal, with really strong magnets. And then I walked away and I came back and it was like this. But that's kind of where I'm exploring right now, is mechanically fastening this down. And printing inside of an enclosure, heating the enclosure. I don't have the heater yet; it's on order. So there are lots of things to do. And actually, I've been working with a professor at Michigan Tech, who's big into plastic recycling and open source stuff, and just so cool, Joshua Pierce. And that'll be something in the resources when we get to it in just a minute. But he's been helping me with ideas. So I'm waiting for my heater, and I'll try that and just, keep plugging along. So when you are looking for a 3D printer, some of the things that you want to take into consideration is, does it have room for the pellet extruder that you want to use? When you fasten that pellet extruder onto the y-axis, you can put it up as much as you want so that your nozzle is, you're not taking up any extra space. But of course, it's going to be higher. And so when your y-axis goes all the way to the top, you have to make sure that it's not going to hit the gantry or other things. So you want to make sure you have room. You want to make sure that your printer can handle the weight. We talked about that a minute ago. We talked about making sure that it has all the proper connections. And I'm sure with heavy enough research and probably phone calls, you can figure those things out without actually buying the printer and buying the extruder. I was such a novice that I just kind of did it backwards and bought it, hoped for the best, and it worked out. But hopefully you can learn from me. Oh yeah, okay, so I was going to start with this and I forgot. I'm $11,000 into this. One of the things that I wanted to achieve with this presentation was to hopefully save you guys some money from going down, that path, oh, wrong path, that path, nope, that's not a good path, that path. That's a lot of money I don't have anything printed yet. So anyway, all right, so that was connections. Another thing that you want to look for is, and this is more generic, this is not so much for pellet extruders, is a heated bed. That's just going to increase the possibilities for you. You'll be able to print with more materials. It's almost standard, but not completely. You want to look at the build volume. So if you want to print a standing a floor lamp, you need to make sure that that printer is going to accommodate, how big you need it. And dual Y limit switches. So your y-axis in some printers is actually moved by just one motor. And if you have two motors and two switches, so basically when it hits the end, it's not going to go further on one side than the other because it's got a switch on both sides. That's going to keep your y-axis level with your bed, which is everything. If it's not level, if you're trying to print and it's like this, it's going to be all squashed on one side and fall on the other. So something to look for. Somebody had their hand up a moment ago.
Yeah, I have a quick question. It's about the 3D printer considerations. Are you familiar with the mostly printed CNC machine? And do you think it would be a suitable printer for these pellet extruders?
It's called mostly printed.
Yeah, you should really check it out if you're not. It's a CNC machine that uses aluminum conduit and 3D printed parts.
Cool.
Yeah.
So no, I'm not familiar with it. However, can you mute your phone? Sorry, I'm hearing myself. Thank you. One of the printers that I put in the don't have time for it today is a printer that is installed on a CNC machine. So I would think that you would be able to put one of these extruders on a CNC machine. I don't know enough about them. I don't know how you would control the thermistor or the fans, because I don't think that CNC machines have those things originally on, the machine, and therefore connections on the board. But I would totally love to look into that. I just wrote it down so I don't forget. So maybe.
Yeah, awesome. I think
answer
some of the
can be-
electronics are already some of the electronic architecture is already there, because a lot of people do adapt it for a 3D printer head, probably not as large, but a 3D printer head, a CNC device, even like plasma cutters, people have put onto these things. So yeah, thanks for filling the question.
Yeah, I would think that it would be a really good sturdy option. I think that CNC machines are less tend to be a little bit sturdier because of their gantry on the top. All right, let's see here. So now I'm going to talk about challenges and best practices. This is just a tiny list of the actual challenges, but these are the ones that are really getting in my way. Well, a couple of them are really getting in my way. So the first challenge is your feedstock variability. When you shred plastic, obviously the little pieces are different sizes, different shapes. Sometimes they're elongated. So, you think that, gosh, this is very hard to show. You think that it's small enough because it fell through the little holes in the shredder, but that's because it was pointed this way and not this way. So you have a lot of variability in your feedstock. And you actually have a lot of variability with pellets too. They're not always cut the same length. They're long on one side, short on the other if they were cut from an extrusion. And 3D printers don't like that. 3D printers really expect filament that, like we talked about before, is consistent, very, very high tolerances or low tolerances. It needs to be perfect. So the kind of issues that you're going to get with having variable feedstock is that those pellets, as they're going through, actually can just kind of get hung up on themselves, and so not continue on to the auger. And so you'll get zero extrusion or variances in extrusion. So it goes through, sure, but because you don't have a super long melt zone or whatever their case may be, the pressure that is being exerted on that plastic at the hot end varies, and so you might get under extrusion, regular extrusion, under extrusion. So that's one of the things that I'm wrestling with right now. I have a suggestion. We'll get to that in a sec. We talked about retraction, so I don't think I need to go into detail on that, except to say that by not having retraction, you might get stringing, and that's going to impact what kind of things you can print and post-processing. Because maybe you can print something and it's stringy and you just fix it up. Maybe that works for your purposes. The other thing that's really hanging me up right now is slicer settings. The slicers are not built to, or programmed, I guess, to know how to deal with pellet extruders. It's a completely different animal. And I'm getting really weird things sometimes, like it'll start on the outside and the brim is just beautiful, so flat and nice. And then prints the walls, and those are all nice. And then it does the infill and it just over extrudes like mad. And can't figure it out. I'm not a slicer guru, that's for sure. But they are programs that are supposed to be, they're consumer programs. They're not super high tech. So anyway, that's a challenge. So those are the big challenges that I've faced. Best practices that I have suggestions on are, let me get my notes. There we go. Okay, so way back when I started, I met with a guy who owns a blow molding. It's not that. It's he makes stuff out of plastic, and boy did he, in not the nicest way, say, "You're never going to be able to do this. This is not going to work." And where he was coming from is when you recycle plastics, the plastic that is in this may be different than, even if it's PET. Let's pretend that this is PET because I don't have a good example. Let's say these are both PET and I want to recycle these together. They are actually going to have different characteristics. They're going to have different viscosity, different additives, things that are going to make them behave differently when you're 3D printing. And so my suggestion, based on what he said, and also a little bit of research in that area, is when you're sorting, try and sort like things together. Of course, you're going to sort plastic types together, all your PET, all your HDPE, and so on. But for example, I wouldn't suggest that you put water bottle PET with the green, 7-Up liter bottle PET, or at least try it and see if it's going to work. And the reason for this is when you are doing all your slicing and changing all those values and getting it all dialed in, you're going to get it dialed in for one kind of PET plastic, from one source. And then, let's say it's water bottles. And then somebody hands you, 50 pounds of green PET from liter bottles, and you've already got, all the slicing settings configured, and it doesn't print right. There's whatever kind of issues. That makes sense because of these different viscosities and chemical stuff that I don't understand. So that's one of the suggestions. Another one is to address feedstock variability. Oh my gosh, it's 425. Should vibrate the feedstock, and you can do that with a small vibratory motor near the supply tube, near the feed throat. I'm going to stop because I did not realize it was so late, and open it to questions, and my apologies.
It's fine. I think it's been, fascinating information. So I think everyone in the community probably appreciates it. I don't know if there's, if we've been kind of asking questions as we go through. So if you want to cover a little bit more, then we could ask questions after. Anyone, feel free to, continue to chime in with questions. I think it almost seems to work better that way than just waiting till the end.
Okay, that's awesome. Yeah, I just have a couple more things, so that's great. Another suggestion that I ran into, and it makes sense to me, is to preheat the nozzle first and then preheat the bed. It gives the nozzle more time to, the whole part, the whole printhead, time to heat up and stabilize temperature, and also get that plastic, getting molten. So that, a slow print rate, I saw it in lots of different places, and actually 30 millimeters per second is the one that I saw in more than one place. And that's so that your plastic has time to melt. So you just have to slow down. And I think I already mentioned having the longest heat zone your printer can handle, so it has plenty of time to melt that plastic. So last thing, if you decide to take on this challenge, think about your goal. What is it that you want to print? What kind of plastic do you want to recycle? Where do you think you're going to get it? Think all that stuff through, because that's going to color your decision for the kind of extruder that you want, the kind of printer that you want. And just because I couldn't make filament cheap doesn't mean that you can't make filament, doesn't mean that you don't have 10 grand, or that there's not another solution out there that I haven't run across to make filament consistently. One of my peers is working on a filament machine. He actually has mine also on loan to see if he can make it work, because he's a lot more tinkery than I am. So, maybe you want to consider trying filament. And then be ready to spend some time really dialing it in, figuring out all those issues and overcoming those. And your issues are going to be different too. Because I'm using polypropylene, I have certain issues that you might not have, and you might have different ones. So be ready to spend some time. If it were easy, we'd be doing it. If it were easy, there would be pellet extruder printers, BAM, that you could just buy at the consumer level, but there's not. They're industrial. They're like the cheapest one I found was 11,000, and I'm shocked actually that it's that cheap. And then it goes up to 16, and then who knows? So that is it. And let me do one more. There. So my contact information is down there at the bottom. Like I said, I'm going to post this. And does anybody else have any questions?
Hey, Cheryl.
Yeah.
When you originally set up your extruder, did you happen to try like everything at spec, like the perfect pellets they wanted and all that, and just to make sure it all worked? And then
That's a really good point. And I failed to mention that. So when you're starting and you're in the calibration stage, don't use recycled plastic. I would suggest that you use virgin plastic, you use pelletized, just give it the optimal conditions so that you can dial it in, and then introduce the shredded plastic or recycled or whatever the case may be, so that you have fewer issues to deal with, and you know which ones are, oh, I'm doing recycled, so these are recycled related issues versus this is a pellet extruder issue. So yeah, good point. And I did.
And you did, and it worked. And then you moved into recycled flake, and
No.
It didn't work?
No. So let's see here.
What do you got to share?
I have to actually, let me back that up. Maybe the extruder behaved just the way it should, but because I'm using polypropylene, even when I was using virgin plastic, I was using polypropylene and getting that warping issue. So, and the over extrusion in the center, and maybe I need to take a class, break down and actually go and learn in a classroom.
So it looked like there was a question about what other filament extruder machines you tried.
Oh, I only tried the fill extruder. However, in my notes, let me.
Yeah, I tried. Someone gifted me the like original fill extruder that was like started on the Kickstarter or whatever, and used it a little bit. Was able to make some stuff, and then at some point it got clogged on me, and then I was never able to figure out how to get it unclogged. But I hope to put not just the pellets that they provided in there, but I never got to try any recycled plastic through it, but it was a very crude, just a little pipe with a drill, and the most sophisticated thing was the nozzle. I think that was what was kind of like fancy machining. Otherwise it was just a simple heater band and a motor and a temperature controller.
I'm trying to find in my notes, there is a extruder that if I were to go back and try again, I would want to try. And of course, I'm not finding it. Right, here it is. Okay. I would want to try the RepRap Recycle Bot. So RepRap, for those of you who haven't heard that term, basically it's a term applied to things that things that replicate themselves. So the Prusa that I have, the Prusa printer that I have is a RepRap printer, meaning some of the parts on it, a lot of the parts on it are 3D printed. And so you could, get this RepRap printer and then use it to make another RepRap printer and so on. So anyway, this Recycle Bot is that. And it's about $700 for the parts. It's open source. And it looks really similar to the Filabot, which is the system that is off the shelf here, make filament. Not industrial or pro, but more like prosumer because of the rate at which it produces the filament. So don't remember your question, but that's that's an idea for creating filament. That if I were going to try again, that's what I would explore. Any other questions? You guys have been awesome. I really, really enjoyed the questions. I really thought that, yeah, they're surprising. They're different than I thought that I would get. So that's really cool. Made me think. And there's like 8 or 9 other printers. Go ahead.
I just had a question. What's next for you? And if someone wanted to say collaborate, or like how can the precious plastic community help? I know that it sounds like you talk with Richard frequently, but I could imagine others here might want to get involved, maybe try out some things on our own, and maybe as kind of Precious Plastic LA, I always like the idea of thinking of like, okay, how can we get a machine that could be used by anyone in the community, right? So you're going through all the troubles of having the learnings, and do we kind of create a fundraising campaign around the one that's the best one, and try and get one of those somewhere that could be almost a shared resource. That's my hope, but I guess I was just interested to know what you kind of see as the next steps.
So on a small scale, I have a few more things to try. I do not feel like I've exhausted the possibilities for this extruder. I'm waiting for the heater. I need to get that little vibratory motor. I need to change the, sorry, I'm looking at it. You guys can't see that. So I need to change this little throat where the feed, the material goes in, because it's getting caught up in there. And I think the problem is the design on this. So there's some stuff that I still want to try out. However, I do have another extruder on order, the Lily. And so regarding collaboration, I would love to collaborate with somebody who knows slicers. And I would be totally down with lending this out for somebody to try. Doing it remotely, it's just too hard. So, I can't just, I'm getting a little bit of help from that, Michigan Tech guy, but it's so much easier to make a change, print a little bit, tweak a little more, print a little bit, and iteratively. So yeah, I would be absolutely down with lending it out once I've played with it just a little more. So yeah, I think that actually we can talk more about it, but maybe you could post on your guys' Facebook page, help Cheryl and get to play with this printer.
It looks like you've been using the default, the printer, the print bed surface that came with the Prusa. Have you tried alternative print bed surfaces like packing tape or
Yes.
coatings?
Yes, what a good question. So I have used polypropylene tape. This is the latest one, but I also had a red one that was super smooth. You can see that this one has like fibers in it, because the red one, when the plastic worked, it actually pulled the tape right off the print bed. So I went with something that was stronger, and it wasn't strong enough. So that's why I went
has to be rated for the heat as well.
I'm so sorry, say that again.
Oh, I'm sorry. The adhesive on the back of the tape probably gave out under heat before the plastic itself did. Dang.
Yes, and boy, what a mess it leaves. Now, the other thing that I tried was a silicone sheet. So I didn't try it again. This is actually the one that I didn't use. The one that I did use went in the trash, but it sticks on, and it stayed stuck on. This is made of polypropylene. However, which is good because polypropylene sticks to polypropylene, but it stuck too well, and I could not get my print off, which is why the other one went in the trash. And some things I tried. And kept trying, and some things I tried once and just went and moved on. So this is actually, I'm glad you mentioned this. I think I might have to try this again. They replaced it for free, which was very sweet. And perhaps if I print with a lower temperature, it won't adhere quite as well. And so maybe I can, get the print off. Richard, you want to see the product? Let me see though. If anybody has any other?
Are you?
Any other questions?
I had one question. Did you happen to kind of see if like we can use recycled plastic in construction 3D printing as well, or like have you seen any example of it before?
In construction?
Yeah, like if we can mix it with concrete and use it in construction 3D printing.
Yes. Okay, so not construction and not polypropylene. However, that same professor, Joshua Pierce, has a ton of articles that are published and available. And one of them, they combined they combined other waste products with plastic and 3D printed with that. And so I'm not sure that I'm really answering your question. I'm not sure that I understand your question.
Yeah, I'm just, because my company works on like turning recycled plastic into construction material using construction 3D printers. And we are working on like figuring out different ways that we can use like recycled plastic. Can it be just mixed on a hopper fed 3D printer and just like be 3D printed, or can it be separated? So I was just wondering if you had any experience, or if you got to see any example of it, like while this like being on your journey. And I would love to read the article. Would you mind sharing that with me?
Absolutely, yes. It's going to be in You know what? Let me actually just put it in the chat. Oh, wrong place. One other place. All right. This is not to that specific article, but this is to one of his articles, and it's on the same site as his other articles appear. So let me go ahead and put that in the chat. And so if you go to academia.edu, what I've done is I've subscribed, and like every day I get another article from him. Of course, they're all already published and they're, you know, from previous years. But that's how I found out about the recycle bot. That's how I found out about adding those waste materials to plastic and extruding them during 3D printing. The thing that your question makes me think of is, so I don't know if you've seen lately, they are 3D, yeah, yes, that's what I was going to say. They're 3D printing houses out of concrete. And imagine, you know, if they layered in, or not layered in, but within that whole mix, they put flake plastic, how pretty that would be, one. But also the nozzle. So I was talking to a guy who owns a company that makes 3D printers, industrial 3D printers, and I can't remember the biggest dimension, but it was at least 40 feet. Like your print area, one side could be up to 40 feet, just crazy big. And so think of the nozzle size on that. Yeah, I can't remember the biggest nozzle size, but they're big. So of course you can put flakes of plastic in there. It's not going to clog up. So yeah, that's a fantastic idea. And let me give you this website. Too many screens. Oh, it's the name of the company is Erectorbot. No, Erectorbot. So I'm gonna post that in the chat.
And
he actually might be a good person to talk to.
Mariah, who was just asking the questions, I know in the chat she was posting a little about her company. That sounds like they make recycled plastic 3D printer filament. Is that correct? But just wanted to give you kind of the floor for a few minutes to share what you're doing, just so that the community can learn about it.
Please.
Sure. Yeah, so I started this company and which we are planning to use recycled plastic, mix it with concrete, and create affordable housing with it. That's basically the main idea. And I just graduated from like a pre-seed accelerator, and I am at a stage that I'm creating my MVP, where we are testing the material, and also like we are also looking for material scientists to join the team. And at the beginning, we are just like looking at turning into construction material, and our ideal like next stage will be using it in 3D printers to create affordable housing. And now I am looking for basically a lot of recycled plastic, a lot of shredded recycled plastic to just use for testing the material. And I've been like connected to Richard, which I'm going to talk tomorrow. And also Marcus, I think I sent an email to you earlier as well, and I got a connection to talk to another person. So I was just like trying, and now I'm just looking for like, because I bought like plastic from one of the precious plastic like owners from Canada, and I got like 1 kilogram for like more than it cost like more than $70 to be shipped here, and I just could use it for one sample of my material testing. So I'm like, I truly need more plastic, and I cannot afford to pay like $70 per test, right? So I need, yeah, so I need like to find a place who is like willing to give me some plastic to experiment with, and it's like, so we experiment this with the different materials, and then we will send them to the lab to test their like structural abilities, their compressive strength, their tensile strength, and it's feasible. And thank you so much, Megan. I've read those articles. I'm in connection with Modbots as well. Those are really good sources. And yeah, so we're looking for basically like onboarding all these scientists who have been working in the world of like using recycled plastic in concrete. And we're trying to just like create like this, but basically bring this product to life. That's my goal. And yeah, I'm looking for like people who are interested in joining the team, like material scientists, and also like recycled facilities that we can just get some shredded plastic to just run our experiments with. And I'm very happy to be a part of this community as well. Thank you.
Yeah, well, I think
So Maria,
having
Go ahead.
finding recycled or plastic to recycle is in general not the problem. It's more about coordinating how you get it, and that's part of what we hope this community within Precious Plastic Los Angeles can, through our network and kind of everyone who's passionate about this, get organizations like you the recycled plastic you're looking for. So definitely, I think myself and Richard and Armando's on here. He I think has way too much plastic that he doesn't know what to do with as well. So that we'd love to help you figure out how to source it locally. So
That would be wonderful. Thank you.
yeah, I have a couple of leads
any other
as well. So so let's exchange information after this, Marcus. You can pass me her information or vice versa. And I know where to get some for free, like 50 pounds here, 50 pounds there.
That's wonderful. Yeah, I think I found like I have your email address from the information you shared at one of the the end of the presentation. I'll send you an email. Thank you.
Awesome.
all right, anyone else have other questions or things that they'd like to share with the group here as well before we kind of wrap it up? Guess we'll leave it at that. So yeah, just to give everyone a preview, next month we're planning to have Sophia Ratkovich. I don't think she joined us today, but she runs a company called Zero Waste Co. So it's aligned with the mission of reducing plastic pollution, but she's more of kind of an expert here at helping people learn to have a zero waste lifestyle. And her organization actually really focuses on helping people zero waste their events. So she'll manage all their trash, but then she even like for large events, which really aren't going on right now, but some of those ones she had like rentals of plates and cups and silverware and those types of things, so that people don't need to use single-use plastic and paper and those types of things. But so it should be she's one of our early members of Precious Plastic LA. She helped out at really the first big event that we had, was real very helpful there. So her should be a fascinating talk as well. And we're still finalizing the date, but it's probably going to be the last Sunday in March. So keep posted about that. And if anyone else has other ideas or you'd like to speak yourself, we're happy to have ideas of what we can do, and add speakers in. We are kind of brainstorming the idea of having where each month people could show off creations that they've made out of recycled plastics, and then maybe we'll have kind of a prize, kind of a community vote for who has the coolest thing, and haven't yet determined what they would get, but just a way to, as we're all distributed and remote and trying to find better ways to connect, a way that we can all share things. So but please email or send through Instagram or Facebook, however, any other ideas that you guys have or ways you'd like to engage. So thank you very much. And we'll see you
Thank
all
you.
hopefully in person, not too far from now.
Yeah. Thank you, everybody.
Thank you, Cheryl.
Bye-bye. Yeah.
Thank you very much.
Thank you, Cheryl.
Thank you, Cheryl.
Thank you, everyone.